Here we have the integral of secant squared x minus 1 under a square root evaluated from negative pi over 3 up to pi over 3. So the first thing that we'll do to tackle this one is we'll rewrite it, but we'll rewrite it as the integral from negative pi over 3 up to pi over 3 of the square root of tangent squared x dx. This of course draws on the fact that tangent squared x equals secant squared x minus 1. Now, what we have is a tangent squared and a square root symbol, and so what we can do is get rid of that, and we can rewrite this as the integral from negative pi over 3 up to pi over 3 of just tangent x dx. Now, one thing to note about tangent as a function is it is even, and that means it's symmetric about the y-axis. And because of that, we can actually change our bounds here. Because we have negative pi over 3 and positive pi over 3 about a symmetric even function, that means what we can do is rewrite this as 2 times the integral from 0 up to pi over 3 of tangent x dx. Effectively, we're just cutting the domain in half and then multiplying it by 2. This allows us to use 0 as one of our bounds, which makes integrating significantly easier. So, tackling tangent now, we must remember that tangent is simply sine x over cosine x, and so this can be rewritten as 2 times the integral from 0 to pi over 3 sine x over cosine x dx. And now we just perform a fairly straightforward u sub, so we can let u equal cosine x. The derivative of u in this case is negative sine x dx. And so to solve this, we'll go ahead and pop the negative out front, rewrite the integral over 3, and then let it be 1 over u du. And of course, the only thing left to do now that we've done our u sub is to go ahead and change over our bounds. So what we have already is when x equals 0, or when x equals pi over 3, we now need to plug these values in here to get a u value. So we can say u equals when x is 0, cosine of 0 is 1. When x is pi over 3, for this we can draw a triangle. Pi over 3 will be here. We will have the square root of 3 there, 1 and 2 on the hypotenuse. And of course cosine is adjacent over hypotenuse, so we'll have 1/2. And so now we can actually come back to our integral and change what we've written already. So we can change this to 1 on the bottom and then 1/2 up top. And because we've got a smaller number up top than the bottom, and we also actually have a negative there, we can do something fairly unique. We can go ahead and change the sign out front, make this a positive, and then flip the bounds. So we'll have the integral times 2 of 1 up top and then 1/2 on the bottom now of 1 over u du. And of course when you integrate 1 over u with respect to u, you are given the natural logarithm of the absolute value of u. So we have 2 times, in brackets, the natural log of the absolute value of u integrated from 1/2 up to 1. And so now we can evaluate this. What we have is 2 times the natural log of the absolute value of 1, which is just 1 in regular parentheses, minus now the natural log of, again, in just regular parentheses, 1/2. Of course, the natural log of 1 is 0, so what we have is 2 times the natural log, negative 2 times rather, the natural log of 1/2. And you could manipulate this if you wanted to. You could, distribute this negative 2 as an exponent. You could break apart this quotient inside of the natural log to make it 2 different natural logarithmic functions. Typically, though, I would just leave it as negative 2 times the natural log of 1/2. And this is the solution to the integral. If you have any questions, leave them in the comments below. Otherwise, I hope that you found this helpful.